Hello everyone, my name is Sean along with my partner Chad, and for this video we'll be discussing SQL injections. What is an SQL injection? SQL, or a structured query language injection, is best described as a vulnerability that results when the one that is attacking could influence the SQL queries that the application passes to a back-end database. It is a code injection technique that is commonly used to attack data-driven applications. They are known as malicious statements that are inserted into the entry field for execution. So you ask, how does an SQL injection happen? SQL injection happens when a developer accepts user input that is directly placed into an SQL document and doesn't properly validate and filter out dangerous characters. For this example, we'll be demonstrating a union-based attack. A union-based attack is used by the attacker when both queries of the SQL structure are similar. It is categorized as an in-band or a classic structured query language injection, in which the attacker uses the same channel of communications to launch their attacks and gather their results. For our demonstration, our plan of action will be to create an application with a vulnerability, which is what we already did, create a web interface, which was already done, utilizing a virtual machine, host both database and interface, use a search bar injection, and access information we shouldn't be able to see.
We have some assumptions before we start. We assume that MySQL is being used. We will prove it later, but we're just going to assume that. And that if this was coded properly, there would be wildcard characters on both sides of the query, but due to time constraints, I couldn't get both wildcard characters work on both sides. So this is our website we made, amazing.com. We have it hosted on an AWS EC2 instance, T2 micro, free Ubuntu server. So we have it developed here. So this is what this is. We have a web store here. It's like something like Amazon. So you just type in stuff that you want, and you should get results. You have the price, you have the item name, the price, and the category. So we're going to try to figure out exactly how this query works. The way that a web store like this works is it puts this phrase inside of an SQL query. So what we're going to do today is figure out exactly what this SQL query is selecting, from where it's selecting, and how it selects things. So we typed in phone already, and we saw that iPhone got returned. So let's type in own. So iPhone still gets returned. So we know now that in this here, we are at least have a where. We're going to assume it's called name equals, and then that there's going to be a wildcard character here. And what that means is that if it'll return anything in the database that ends with whatever the text is. So let's see if there's a wildcard character on this side. So if we type on, we should get iPhone to return, and it doesn't. So that shows us that there isn't a wildcard character here. Again, normally on a search engine there would be, but due to time constraints we couldn't get the programming to quite get it. So now we know that we have what some of the where looks like. So let's see if this is secure by typing in just a single quote. It should just escape out still and search for anything that has a comma in its name. So if we search, nothing gets returned. So that's not a very good sign. It means that it's not escaping out. So we're going to see if we can get it to display everything. So for assuming this is what our query looks like, and I'm going to get rid of this for simplicity. If we were to type something like this, we've now escaped out of our out of the query, and if we type this, now we're able to execute our own set of commands. So since we've already ended our query, what we need to do is get this part to go away. So what we're going to do is comment it out. You can do that either by double slashing or just be double dashing, or using a pound sign. I found that pound sign works normally, um, as opposed to double dash, which gives me errors. So if this works, it should return every item in our database, which it does. Now that we've proven that we can SQL inject into our database, we're going to prove that we're actually using MySQL. Since we figured out earlier that this is what our query looks like, we should be able to prove it's MySQL now. Normally, in an SQL injection attack, you have to figure out what databases this is being run on. But again, since we have the assumption for time constraints and simplicity that it is MySQL, we're going to prove that. So, since we figured out that that was what our query was, and that there's a wildcard character here, anything if we type in E, it should return anything that ends in an E, which it does. It returns 5 items. This is important because MySQL has a sleep function, and what it will do is it will wait however many number of seconds you put in here to return all of the rows that it finds. So what this should do, if it works properly, is it should put an E here, so it's going to turn everything with E, which is 5 things. And now we've escaped out, so we're able to add our own modifiers to the where clause. So whatever we type will get executed. So now, if this works properly, it should take exactly 10 seconds to load all 5 rows. Which it does. Since we're able to execute our own SQL code, we're going to try to pull information from tables that we normally wouldn't have access to. The way that this is accomplished is with a union. Unions are just like joins, except for instead of adding the columns, it adds rows. To do a union, you must have the same number of columns in both queries, and they must have the same data type. So one of the key things with unions is that both queries must contain the same number of columns. So we're going to try to figure out exactly how many columns are being output when we type something like E, for example. It looks like 3, but in the back end there might be more being called. So this is our query that we're going to use to test how many columns are being pulled. My theory is that since when you type E, you have the names, the pricing, and the category, that it might also be pulling the hidden backend identification number. So what we're going to do is try to we're going to try to pull the numbers 1, 2, 3, and 4 from the dual, which is the placeholder table. So that didn't return anything. So now let's try it with only 3. Maybe the backend identification number isn't being returned. So it's only 3 columns. So now we know that there's 3 columns being returned from our query here. So we know that we now have X, Y, and Z we need to figure out. A neat thing about MySQL is that there's a lot of metadata stored in each schema. So we can access that. So all we have to do is change our union query a little bit because we're already able to pull stuff. So what we're going to do is pull table name data and table schema data. So now we have our query typed out. We're going to pull the table name and the table schema and 3, since we have to return 3 columns for a union, from the metadata table, and we'll see what we end up getting. So now we have a whole lot of metadata to sift through. And if we scroll down, eventually I'm sure we'll find something that's useful. And we find the items table and the users table. So now we can assume now that what we're doing is pulling stuff from the items table. Now we're going to find some information about the users table. So what we're going to do now is we're going to try to figure out the column names from that table. So instead of using table name, we're going to call column name And we don't need table schema anymore, so we're going to replace that by the 2. And instead of pulling from information schema.tables, we're going to pull from information schema.columns. And since we don't need the information about all of the tables, we're going to add our own where statement. We're just going to pull from the users table. So if we just run this query, we should have some metadata here, but then we have this ID, name, password, and role. So now what this lets us do is go back. Now all we have to do is this query, and as well as our ease, we will return all of the information from the users table. Now again, in a normal non-test environment like this, these passwords would be encrypted, but just for our purposes, they were not.